3, 1, 2.
So this is the room for the LP1 workgroup meeting. If you want to do packet over helicopter carriers, you're in the wrong room. And with this, we're going to start. We'll delay a little bit passing the blue sheets because we're used to some people who are low power workers and arrive later in the meeting. But yes, so we'll pass the blue sheets in like 10 to 15 minutes. And with this, the meeting starts. So please sit. And the rule is the latecomers are the one who take the minutes. So Georgios, you have to take some minutes. Laurent, you have to take some minutes. Okay. Okay, so this is an official IETF meeting. So the best practice documents apply, in particular the BCPs about IPR and patents. So if you're aware of any IPR on some topic that is being discussed today, please mention it to the room or let the chair know after the meeting. This meeting is being recorded, so it will be published on YouTube, I guess, as usual. We'll be recording the presence on the blue sheets. We'll be passing the blue sheets in like 10 minutes. Please join the Etherpad. So the link is given here. This is where we take the minutes. And mostly if you come to the mic and make a point, please make sure that your point is correctly captured in the minutes. So the best way for doing that is actually to participate to the minutes and help us take them. So all this will be published and made available on YouTube. So
just one point, we would like to thank our minute takers for today. So we have a couple of main minute takers. So Ivailo and Laurent and Eduardo, who is a first-time minute taker. So great job. And also our Jabber scribe, Yorgos. Thank you.
So Dominique is also late. So Dominique is also invited to take minutes. So that's a rule now. You better not be late. You're late, you take minutes. Okay. Suresh should take minutes. Okay. So with this, we have a pretty full agenda. So it's 2 pages. Okay. You were quick. So that was the bashing.
Okay, agenda bashing. So if you...
Anything you want to change about the agenda as proposed? So we'll be talking about the hackathon, static context, Sigfox. Then we'll have Olivier, first time at the IETF, presenting the SHIC over LoRaWAN. Then Laurent about the Young model. Then we'll talk about the progress on the static context for CoAP. And Dominique will update us on the OAM work.
So that's a small reminder from our last time. So we have our first charter item that we have completed, and we are working on the second charter item. We are really advanced, and that is something that we are really happy with. And the 2 chairs and the whole working group, I think that we can be proud of ourselves, and you can be proud of your work. So we got all our milestones in green. We have submitted everything, and so the main document, that is the SHIC static header compression, is now submitted to the ISG for publication, and it will be passed on to the secretariat and to the RFC editor very, very soon. So Suresh is going to give us.
Yeah, so Krishnan, so the SHIC stuff is like gone through the IESG eval. It's ready for approval, so I'm ready to push the button. We are expecting one review from Karsten on the side. So we're kind of holding off for a little bit to see if something comes in. So, but we are until the end of next week before we approve. And also, Dominic was just telling me, there's some XML v3, XML to RFC v3 stuff that requests we change, but it doesn't change the content. It only changes the source file. So it shouldn't be a big deal process-wise for us to do. And the co-app, it's on my AD-eval pile. It's like a long pile now, so I think I have like 11 documents or something right now. So I'll get to it probably I would say about before end of the year for sure, and hopefully as soon as possible. Okay. And for the I also talked to the RFC editor. I know like Alex did as well, and Pascal, I don't know if you were there too at the same time. We could go for a expedited request to the RFC editor to make sure that the stuff gets done a little bit faster. So you can give the number to the external SDOs who want it.
Yes, and thank you so much, Suresh. Actually, very appreciated, because as you know, it's needed elsewhere. We need this RFC number. This picture tells us a lot of things, right? It tells us that we are really ready to recharter.
I'm good. Like I know, like there's a charter been kicking around for quite a bit. It's been pretty stable. So whenever you're ready.
So we'll have a discussion on the charter a bit later, which is now. And so if you agree, then we'll just send you an updated charter. And
sounds good. Like send me the stuff. I'll kick off the procedures. Yeah.
So here, the only points on all the things are as we discussed a couple of times already. So here, what we would like to propose is to modify slightly item number 1, which before was really focused on co-op. And right now we see that there is a lot of interest in actually having other protocols, operator protocols to be using SHIC. So we said, okay, how about we reformulate this in a little bit more generic way, and to say, okay, well, if there is some protocol that comes bar over SHIC, then we can be chartered to do that work.
And that's fine, right? Like the only thing is like the milestones need to be more precise than this, because you cannot say, hey, I will send borrow or something, right? Like without knowing what bar is. But so the charter can be like a little bit wider, but as long as the milestones are known at the point we send them across.
As for today, we will not have any deliverable associated to item 1. But if somebody comes to the room and say, oh, I've got this technology like we had DLMS, for which we would need to add a feature to SHIC, then we would be capable of adopting this group because of the first statement. But so far, and then we would have an item in the list. But so far, there would not be an item.
No, that's fine. And like adding a milestone is like between you and me, right? Rather than the IESG. So I think like the charter, like as long as it's like clear to everybody what needs to get done, and the milestones are specific things you already know about, I think it's okay.
Okay, so we'll publish this. We'll send you this text.
So yeah, we'll send you this text and we're good to go. So with this, we can go on to the first presentation from Dominic. And so for all people that are first time on the attending at the IETF, you can go to the IETF website, the meeting materials, and then you can see you have all the presentations, you have all the links there.
Hello. So as you may know, there was a hackathon weekend before this week, and so the SHIC community had a table at the hackathon, and I'm going to tell you what we did. So first of all, this is the team. About a dozen people showed up. The usual suspects, Cedric, who's our technical lead, Laurent, Soichi from Japan, who actually flew in on his own money just to be with us physically. He usually is remote, but this time he decided to come. Thank you, Soichi, for doing this for us. Arun as well. Olivier, a first-timer, first time at IETF, first time at the hackathon, very good technical expertise. He did a lot of stuff that we hadn't done before. Rahul, who's a long-timer at the IETF, but first time at our table at SHIC, and he dived into the code as well. And then usual suspects, Juan Carlos, myself, Sandosh. We had Diego, a student at University of Chile, joining remotely, and Guillaume, a local colleague of Juan Carlos, locally in Singapore, and Ryan from Japan. And we mostly worked on the open source implementation of SHIC, which is called OpenSHIC and is available in GitHub. The link is available here. But we also worked, some of us also worked on other implementation. So the hackathon goals was to advance the implementation of Check in the open source implementation, and especially touching two drafts, the one that's a generic check mechanism and the other one that's how co-op is compressed by a check. So these were the two bases for the work. Our goals were to clean up the repo because we had quite a few diverging branches before, and Cedric did a lot of work before the hackathon to merge everything, so we had a clean repo to start with, and then we could remove that code, we could rename files, restructure the repo, etc. Improve documentation, we worked quite a lot on creating a better doc so that people joining the project can understand how to work with the code and how to run it. And also we improve functionality, fixing bugs, etc. And Olivier set up the Travis continuous integration tool so that we have a non-regression testing automated. And then Juan Carlos, Guillaume, and Diego worked on the implementation of University de Chile, which we nicknamed PyCheck. And so, yeah, a great lot of activity. I think on OpenCheck, you can't read that, but we had nearly 80 comments on the OpenCheck, and you can see, the graph of everybody everybody working on the code, fixing stuff, merging, branching, etc. And it's all converged into one source code, one documentation at the end of the hackathon. What did we learn? What's left to do for the next hackathons or the time between hackathons? I think everybody understood the Check specification better by trying and implement it. We spotted one interpretation detail of the specification that right now we say that the fragment receiver must have an inactivity timer, and Arun pointed out that in some cases when DTAG is not used, it would be better for the sender to have the inactivity timer as well, so that it can guess what the receiver is being doing. So that was a useful addition in terms of understanding the specification. We spotted a missing element in the data model that will help the future draft on that. We spotted issues, of course, in the OpenCheck implementation. That's the whole purpose of the hackathon. We fixed some of them. And basically, we realized that more tests are needed. That's why we put the test automation in place. And we also need to be better at reporting the issues and missing features. And so we're going to use the issues of GitHub better in the future. And also, because now we have several implementations of Check, we started floating the idea of doing an interop next time at the hackathon. We'll see if this can fly and under which framework. That's it for this one. Questions on this? No.
So thank you very much. And Dominique, if you can tell us about the next topic.
Okay, so this is a second presentation on the Check compression and fragmentation draft. So we're now in Rev 22, and as Suresh mentioned, we passed IESG review, so I'm very happy of that step. Just for the newcomers in the room, I'm going to spend 2-3 slides just to remind you about what this draft is about, and then recap the changes since 105 and what's left and what's ahead of us. And then, depending on your interest and time, we can go through the changes with it or on the draft since the last version. Sorry for the old timers, you've seen that a couple of times already, but this draft is really 3 drafts in one. It has the header compression engine specification. So it's a generic engine. It is not attached to any upper layer, any lower layer. It's just a mechanism to do compression using a static context. hence the name SHIC. So typically this would sit here below IP if you want to compress IP headers. The same draft also has a fragmentation protocol, and this protocol comes in 3 flavors, hence the 3 boxes here. We could have more flavors later on, but right now we have 3, which address the needs of various LP1 technologies, various situations. And also the same draft also has a description how you can use that to compress UDP IPv6 in simple situations where you have no extension headers. And it's fairly simple because UDP IPv6 have fixed fields that occur only once in the headers, so the matching is pretty easy and the compression is pretty easy. So I see it more as an example of how you apply it rather than a specification. And just to set up the context for this work, there are other related drafts that do more than UDP IPv6 compression, typically compressing the whole stack, CoAP UDP IPv6. And this gets more interesting because now CoAP has headers that are optional, that occur multiple times, that are variable sizes. And so this gets really more complicated. And that's why we have a separate draft for that. And Laurent is going to talk about it later. And then applying SHIC to various LP1 technology also needs selecting one of the 3 modes and setting parameters for the fragmentation. And that's why we have drafts for applying SHIC over Sigfox, applying SHIC over LoRaWAN, and others, and NB-IoT, and we have presentations after this one. So what has happened? The draft was submitted to ISG review. It went on the agenda on August, for the agenda of the August 27 ISG telechat, which is the meeting between all the ISG members to discuss new drafts. So I was on the call, Pascal was there as well. There was no specific comment on the draft at this point during this telechat, which is meant to raise critical issues that would hinder the review. So there was none. The good thing about this is that because it was on the agenda for this date, many of the ISG members did their review before that. So we got quite a lot of reviews in a burst fashion in the 2 to 3 days before this meeting. And so the initial verdict was there were 3 ISG members who set up discusses. So they were not entirely clear or happy about this draft, and they wanted to engage into a discussion. And the good news is that these 3 are now cleared. So here are the names of the ISG reviewers who provided reviews. Thank you to all of them for the time they spent and the effort providing comments, and for some of them very minute reviews of features in the draft that they liked or didn't like. We got a few reviews from people who are not on the ISG board, namely Brian Carpenter, who did a voluntary review, got to hear about the draft and read it and provided comments as well. And who else? Anyway, there's another one hiding in this list. I can't remember right now. Or yeah, I think it's Joe Saloui, who did the SEC early review, or GenArt early review, sorry. And so after that, we spent nearly 2 months addressing those comments. We got a whole bunch of comments. And the net result, just within a few numbers, is 36 commits on the source code for the draft, and about a few hundred lines that were changed out of 3,000, which is the source code for the draft. So about 10% of the the source code of the draft has changed as a result of this review. So I'm very thankful for all the reviews we got, and I think it really helped improve the document in various ways that I'm going to describe later. And so we engaged in conversation with all the reviewers, suggesting what changes we would do and pointing them at the commits in the Git so that they could clearly see what changes resulted from their comments. And most of them gave us their approval, and so we knew we were fine by publishing the next version. As a result of this discussion and those changes, the 3 discusses were cleared, so now we're on our way to RFC editing. So what's coming up next? Pushing the RFC editor queue today. Well, probably I was a bit optimistic by saying today. It's probably going to be in the next few days, because I just had a chat with the RFC editor in the hall, and I realized, well, they helped me realize right now we have tables in the draft that appear as ASCII art, and they want this to appear as tables so that it's structured in the document. And so it's either them doing the change and us, it's either them noticing later and us doing the change in XML, or it's us publishing a new version in V2 that has a table, which Markdown, which we use for the editing the document, can do for us. So I'm going to respin the document and make the tables appear as real tables, not ASCII art. So it's a minor change, technical change on a document, not in the content. This will give a few days maybe for Carsten to provide the review that he meant to provide regarding fragmentation, and hopefully we can push that to RFC editor in the next few days. Past that, generally speaking, we want to communicate and educate the community about Czech. That's the whole purpose of having the OpenCzech code, writing papers, having presentation, teaching courses at universities about Czech, which Georgia's just set up a 70 slides course on Czech. That's material for us to educate people about Czech. Continue the OpenCzech development at the hackathons and between hackathons, and evaluate performance, applicability, and again, academics have students working on that as we speak and already publishing about that. Another piece of information that I thought would be useful is the current uses of Czech. So of course, we have drafts at the IETF using Czech, the ones I mentioned before, compressing co-op with Czech, Czech over SIGFOX, LoRaWAN, 9BIOT that we're going to hear about next. And there are a couple of demos that are being shown for a few years already. Of course, co-op UDP IPv6 compression over LoRa. But more recently, DLMS, UDP IPv6 compression over RAW. This was this month, I think, very recent. At Orange, we showed a demo of compressing the co-op headers over LTEM. So LTEM is IP protocol, so we're not trying to compress the IP headers, but just the co-op header over LTEM, and evaluate if this makes sense, what's the benefit of that in terms of power consumption and airtime occupation. And we also had a demo with Aclio and Aclio and Cisco had a demo doing SSH over LoRaWAN with Czech. Under evaluation, we have Daniel Migo with Ericsson evaluating IPsec ESP header compression with Czech. Instead of building his own compression specification, just using Czech as a generic mechanism and apply it to ESP header compression. Implementations, I already mentioned OpenCzech, which is Python 3. Originally, we said it would be MicroPython and run on PyCom. PyCom's devices use a flavor, non-standard flavor of MicroPython. And so quickly, we spent so much time fiddling with the hardware radio PyComs that we decided we would run MicroPython on computers, and MicroPython is a variant of Python 3, so we ended up running Python 3, plain old Python 3, just to advance our implementation quicker. So right now, the status is that OpenShift is mostly Python 3, and that's what we are working most actively on. Again, the URL to the source, to the repo is here. Aclio, private company, has, as far as understood, 3 implementations. One in Go language, 2 in C for the high-end and low-end of IoT devices. University of Chile has an implementation in the PyCom flavor of MicroPython. And our friends at Riot have been saying that implement Shake in Riot, but it's not committed yet. So we're looking at 5 known implementations today, and probably a 6th one coming soon. That's why we think we can start talking about interop. And also, as I mentioned, scientific papers are being published on Czech, so it's becoming, more visible in the community. The first one here is by this draft co-authors. The second one is by some of this draft co-authors and their close friends. And the third one is by people totally unrelated to the Chic draft authors at University of Ghent in the Netherlands. And so it's showing that there is a growing interest in the community to this protocol. Okay, so changes since the 21st. Most changes are the consequence of the ISG reviews and a few reviews we got besides ISG. I've classified them in 3 categories. The functional changes, so these are the huge ones because you shouldn't expect to change the functionality after ISG review. So I've classified as functional changes 2 changes. One is a mistake in the description of ARC always. So it's not a functional change, it's a change in the text that reflects functionality, but the algorithm was intended to work the way it's described now. So the algorithm hasn't changed, the description was wrong, actually. And that was me rewriting it clean slate a year ago. When we changed the way we described the algorithms, I started again from a blank page, and it's, well, you wouldn't expect such a mistake to be in a draft at this stage, but anyway, this happened. And thanks very much to Benjamin Kaduk for spotting this. And, he's a security area expert, and he went so far down in the explanations, following the iterations of the state machines, and he spotted a mistake in the details of the state machine, which nobody else in this group who's supposed to look at the state machine did. So thank you so much to him. This avoids us writing an errata later on, which is always embarrassing. So if you meet this guy in the corridors, you can thank him for being so thorough. And I've also classified as a functional change the fact that we rewrote Appendix F. This was some text that was originally in the main part of the document that we'd moved to an appendix because we did not quite know what to do with it. And accurately so, the ISG reviews spotted that this was a bit fuzzy, and they were right. So we rephrased the problem. The problem is that 2 of the 3 modes of fragmentation are bidirectional protocols. They need ACKs to do selective retransmission. So because they are bidirectional protocols, they require a bidirectional link, otherwise they don't work, of course. And some of the LP1 technologies we're talking about are not quite bidirectional. They are what we call quasi-bidirectional. So there is a downlink channel, but the downlink channel is only enabled right after an uplink transmission. This is a case for class A mode of LoRaWAN. This is a case for Sigfox, for example. And so running a bidirectional protocol over a quasi-bidirectional link is a bit difficult. And so Appendix F provided a solution. But the solution may not be required. There might be other reasons why you have periodic uplinks, like you have an application that's doing sending keep alive messages, and therefore it's providing opportunities for downlink transmission. So maybe you have nothing to do because of the application is keeping this downlink channel open for you. Maybe in some cases you don't have such uplinks for any reason. So maybe you have to do something about it. And so we decided that this draft was about the generic mechanism for compression and fragmentation. And rather than provide a solution to a specific case of specific LP1 technologies, we would just state that we need a bidirectional link, and you may have to do something special if you're running over quasi-bidirectional links. And we leave it to the SHIC over foo drafts to say if you need to do something, and in that case, what do you do? So that is a change that I would qualify as functional. The second category of changes were related to security considerations. Actually, most of the ISG review comments we got, and certainly most of the discussed points, were on the security considerations. And we are not security experts. This is not the security community, so one could expect that. I'm not too surprised. So we did a major rewrite of that section again. We added more cases that were suggested by security experts. Are you sure there is a known attack on compression algorithms? There is a known attack on using fragmentation protocols, which is this and that. How do you fare in that respect? And oh, well, we didn't know. So we had to understand what the attack was, and was it applicable to our case or was it not? And we responded. So again, the free names at the bottom are all security experts. Some of changes were editorial. One change suggested by Alyssa Cooper was change of reference to be normative. So we had a little bit of discussion with Suresh and what was best. But so we implemented that change, made it normative. There was one remaining mistake about the RC2119 language, which was the use of the optional keyword capitalized, which I had not done properly. We fixed the reference, and yeah, we made sure all appendices were referenced from the text, which is good editorial practice. And then basically we did a bunch of improvements in the text, improved definitions, improved descriptions. Well, yeah, you can go over the list. And that's it for me. Questions?
So thank you very much, Dominique. Thanks for all this enormous amount of work that has been done since the last IETF, and thanks to all the authors and all the reviewers. It's really an amazing piece of work, and yeah, thank you. That's it. Yeah. So we are perfectly in the timing. So next on our list is Juan Carlos.
LP1 over Sigfox. Hello.
So hi everyone, Juan Carlos Zúñiga with Sigfox. So I'm going to talk about the draft IETF LP1 over Sigfox and the updates we've done, as well as the 5-SHIC implementation that Diego, Sandra, and Rodrigo have worked out from University of Chile. So regarding the draft, we added a few more parameters for the ACON error data fragmentation and integrity mode. Specifically, we were looking at the fragmentation mode to send this to use cases a text file of 53 bytes and small image of 356 bytes. And for that, we were relying on the implementation that Sandra presented last time from the University of Chile of 5-SHIC, which was very, very useful. So let me jump to the next one. This is the architecture that we were trying for the hackathon, as Dominic was explaining. In our case, we were using the device SHIC on the device. This was a PyCom device. And the server side, we were running it on the Google Cloud using the tutorial from Marco from Google Cloud Platform that allowed doing the APIs to the cloud. And it ran pretty well. It helped us fine-tune and find out a few interesting things that we want to work on the draft. The architecture of the code, this is what University of Chile is doing. They are trying to do it modular so that they can run it equally on LoRaWAN or Sigfox, reusing as much as possible the code. In this case, we were concentrating on the ACON error mode for the fragmentation. The profile that we were trying, of course, was Sigfox. The device platform was PyCom, so the Python code, and the application running on the Google Cloud. I guess if you have questions, feel free to ask Sandra or Diego about, or Rodrigo about the details of the software. Coming back to the draft, and as Dominic mentioned, there are very interesting findings, and that's one of the beauties of the hackathon. In this case, for us, it was, for instance, on the usage of the all-one fragment, because again, the draft gives you flexibility on how you implement it, and this is related to the downlink transmission that you were mentioning, Dominic. For us, of course, there's only one mode of operation in Sigfox, which is you send uplink messages, and only if the device requests, you can open the window to receive the downlink. So we are only doing that at the end of every window, so that we can allow the all zero or the all one to come back. And for the last all one, because of the uncertainty on when it can arrive in the window, we think that it would be helpful to rely on the Sigfox sequence number that comes from the layer 2 as information, and then we can relate and find out if this is the all one is arriving at the right time. So this is not yet in the draft, but that's kind of the things that we definitely want to keep improving and fine tune. Same thing for the timers and the header fields. Tried a few different files and sizes. And now that we're getting more comfortable with this other application, the idea of interop came up. Sandra was very keen on proposing this, and hopefully they will be attending the next IETF meeting themselves. So Vancouver could be a good opportunity and we're at perfect time right now to start planning on how we can work out different combinations of the at least 3 that I know implementations and the 2 radio technologies. Julien?
Hello, can you hear me? Hello?
Hello, Julien. It's you're on the. You have the mic.
Okay, so you rely on the Sigfox sequence number, what you expect to do. So does that mean that you only suppose that your device is only transmitting SHIC packets, SHIC fragments, so no other payloads are available?
Well, in fact, this is information that you always get from layer 2, and what we are doing is, in case the information is being used to feed a Sigfox function, a SHIC function, the SHIC function can rely not only on the payload, but also on the metadata that is coming from layer 2, in this case, the sequence number, and then it can improve the behavior of SHIC based on that metadata.
But
Okay, so
I think the question was, what happens if a packet is interleaved between fragments? A packet.
Sorry, could you speak louder? There's this noise here.
I'm trying to rephrase what I understand is what happens if a non-fragment packet, even not a SHIC packet, is transmitted between 2 fragments. Then the layer 2 sequence counter will increase, but it has nothing to do with fragmentation. If you interleave things.
You mean interleaving?
Yes, interleaving is the question, I guess.
Yeah, well, I guess that depends on the application and whether you are indeed supporting interleaving.
Couldn't that become a problem with you if you use the sequence counter to figure out the SHIC fragmentation mechanism. I think Julien is asking us if you won't have a prime if there is an interleaved packet. Is that right, Julien?
Yes, that's right. Actually, that's what we supposed in the LoRaWAN implementation, that we could not rely on L2 sequence number because of that, actually, because of interleaving.
Okay. Yeah. Well, in this case, I think we keep track of I'm not familiar with the way the LoRa sequence numbering works. In this case, it's sequential, and it's per device. So as long as the overall engine and the device keeps track of the increasing sequence number, you can get it. But yeah, maybe we can discuss this offline and see if we can solve the problem for both in one shot.
Okay, thank you.
So probably, thanks, Julien, actually, for that question. Probably if you would like to do this kind of optimization, then that could be discussed in the group and to see what would be the conditions necessary to use this kind of optimization. Or, because maybe you can say, okay, if to use this optimization, you only need to do fragmentation until the session is complete, for example, without interleaving.
Yeah, that will be a hard
so
one. Yeah.
Maybe there is something to work on, and I think that's very interesting to have this work. Maybe this exchange between the different technology documents. Maybe have a small draft. I'm not sure if maybe both of the drafts can specify how that would work.
Okay.
Or have like one common document that says, okay, optimization of like using of layer 2 sequence number for that use, and then you can have like a kind of a conditions. Okay, what's necessary in order that optimization to be made, and it does sound like a good thing to have.
I just wonder if it's not one of those things that could be in a profile or something. If really we can agree on a method where the layer 2 number is useful, then it could be something that goes in a profile, so it can be on off, or some technologies can use it and some not. But yes, I mean, if it's doable at all, we need to document which conditions, like maybe no interleaving, and then we would document exactly what you win if you do this optimization, right? But the protocol works without it, hopefully.
Right. Okay, and I think that's the last slide for me. Does anybody have any questions? Okay.
So I'll have one or two minor questions.
Yes.
The first one is, do you think that for the next IETF, the document will be, ready for like adopting all the changes that have been made to the general SHIC document, and eventually ready for a working group last call? For the
That'll be my hope, definitely for next IETF to have it ready.
Okay, and the second thing is if you can, if you have reviewed the data model that Laurent has been working just to make sure that all the things that are there actually map to your draft, so that we know that the data model corresponds to something that is used, and that everything that you need is also in the data model.
Okay.
So, okay,
great.
Perfect.
Thank you very much.
Thank you, Olivier. So now we have Olivier, first time at the IETF, so big stress. So the crowd is ugly, they will throw things at you.
Okay, so
be ready.
So, everybody hearing? Yes.
And you've got 15 minutes.
Yep. So I will present the changes on LoRaWAN documents. So what we did since last IETF meeting, some technical points of that document, and discuss the next step with you. Since last IETF meeting, we had 2 drafts published. Very useful feedback from the working group, so we will discuss it just after. So the changes in version 3, thanks to Julien's proposition, we unified the overhead size, because we had a proposition with 1 byte overhead and 2 byte overhead, depending on the size of the packet, and we tried to reduce it to 1 byte only, which is pretty nice on embedded devices. Which means that the check header is 2 bytes, and 1 byte is a rule ID which can be linked to the LoRaWAN F port. For those who don't know LoRaWAN technology, the F port is a byte embedded in the protocol, which allows to differentiate application traffic, like the port on TCP computer or UDP computer. So rule ID match that definition, and we squeeze 1 byte inside. We deleted the DTAG. DTAG has been created to interleave session, which we do not want to use in LoRaWAN, but we try to keep it when we had some space in the header, so we have faster error recovery if we lose some message at the end. But to be able to squash the overhead in 1 byte, we had to put it to its size to 0 and avoid using it, which is fine in the protocol. It's still working, so it's not an issue. We changed the tile size to 5 bytes, which was not a good idea. We'll discuss it in draft 4. There was a comment that the padding value were not explicit, so it's not explicit, it's 0. We added some examples, fixed them because there were some mistakes in there. And did a lot of terminology typo and editorial updates, so the document is easier to read. I think we still have some work on that to do. And as Julien contributed a lot directly in the document, he has been made an editor, and we'll discuss that in version 4, because there had been some discussion in IETF interim. So who should be editor, who should be author? And as we are almost all new to IETF on that document, at least on current editor, we didn't know everything. So what changed in issue 4? It appears that we misunderstood something when we set the tile bytes to 5. So we were limited to something lower than the IPv6 MTU, which were somewhere like 1,265. So we were missing 15 bytes to match IPv6 MTU. We had to change it to something bigger. There was the option to take 6, 7, 8, 9. We switched to 10 because it fits. It's another fit to all LoRaWAN MTU, which goes from 11 bytes to 232 bytes with a lot of values in between. So it was more efficient. The rule ID size, given that, has been fixed to 8 bits because at LoRaWAN SF10, which is the minimum payload you can have in US, you can only have 11 bytes of payload. So there is no room to expand the rule ID anymore, but we don't think it's an issue. If you have any comment on that, we would be happy to discuss it.
Yes, I have just a clarification question. You said before that you use the F port for the rule ID and you cannot use the 8 bits in F port, and here you say 8 bits. So.
Maybe it was a mistake from my side. We use the whole F port for the rule ID, so we have 8 bits. 1 byte.
The F port is limited to 224, no? The maximum value?
Yes, 8 bits.
Okay.
No, sorry. Okay. So yes, good question. In LoRaWAN, some F port values are reserved, like the value 0 and value more than 223. But it's not an issue. It leaves 222 values for the rule ID, minus F port up and F port down, which are used for the fragmentation. So you have 220 values for the rule IDs. Is it clear enough? Okay. Then another good thing to have bigger tiles is that we have a smaller acknowledge because the bitmap size is reduced. So it's great for network downlink capacity. We included a multicast proposition. We are open to discuss it. It will be in the technical detail afterwards. And we moved back Julian from editor to contributor since last IETF meeting. There were experienced IETFers who advised that. So here's an overview of what is a regular fragment. So maybe it will help you to understand what we're discussing about. How does it work? Okay. So there is the LoRaWAN header. Inside the header, which is, by the way, not aligned on that diagram, sorry. You have you have something dedicated to LoRaWAN. We will not discuss it there. You can have some option. Here in this example is 4 bytes, but it can be 0, depending on what LoRaWAN stack need to transmit to the network server. Then you have the rule ID, which is the F port, 1 byte. And you have your LoRaWAN payload, which will be in this case the chip payload, with 2 bits window. So we have 4 windows, the F count, and your useful payload. Depending on the LoRaWAN MTU, it can be 1 tiles or more. In this example, it's 23 tiles.
Olivier? I'm just curious why you did not align the LoRaWAN payload to the rule ID. I thought the rule ID was in the F port, which is the header.
It's an issue. I changed the presentation 2 days ago to have better graphics, and I think I made a mistake. The LoRaWAN payload should be aligned after the rule ID. Sorry. Last minute change never works.
And you have a typo in the name of the draft.
Yeah. I had that a few minutes ago. I changed the master slide, I think so. It works on the first one and not on the others. Sorry. So next steps. IPv6 and LoRaWAN. Oh, did you use the one I sent you yesterday or the day before? Well, it's okay. I'll manage it. It's my fault. I sent 2 drafts, so 2 documents. So IPv6 and LoRaWAN are multicast technologies. So we try to figure out a way to make them work together. So for that multicast downlinks, we selected the fragmentation mode no hack, because we can't have all devices answering to at the same time. It will be a nightmare on the network. So we have no reliability ensured by the cheek layer. It would be up to the upper layer to have reliability, whether by forwarder correction or whatever other method that can be used. The group definition and the LoRaWAN rendezvous for class A device are out of scope of the document, because each network server has different way to declare groups. But for the LoRaWAN meeting points for class A devices, there is already a specification, application note made by the LoRa Alliance. Okay, I think it's not an issue here, and it will be an optional feature. So if you have any comments you want to make on that, please do them, whether now or after the meeting or in by email on the mailing list, because it might be new on discussion on CHIC, so we are waiting for feedback. Yeah, so one slide is missing. I wanted to discuss with you the device identifier. I updated the draft. I included that proposition in my last slide, but it's not here, sorry. So
I don't want to cut you in the middle of your sentence, right?
okay.
Now, so do you have a practical use case for multicast already? Could you describe it?
Yes, firmware upgrade, which is not
firmware.
made by LoRaWAN specification, LoRaWAN recommendation, like DLMS. DLMS is a standard mainly used in meters like electricity or water meters. They want to be able to do a firmware upgrade thanks to DLMS and not rely on LoRaWAN method. So we need multicast for that.
Because I have a feeling that truly the reliable fragments that we have in SHIC today are for unicast, but I also have the feeling that those minds who produced what we already have are capable of producing as well a reliable multicast mechanism. And so I was wondering if we could consider that type of effort, if the use cases are, important enough for this community, whether we could consider start thinking about a reliable multicast for basically downstream LP1. And I see some smiles. Is it all, or is it, yes, interesting. Okay, so please come to the mailing list and let's discuss the importance of those use cases and see if we are interested in having a new reliable multicast fragmentation. Because sending out those fragments, if you have many fragments, and not having any reliability doesn't seem like a good idea to me. Because for each destination you will use maybe one fragment, not the same one, and then you're stuck for everybody. It seems like either you do a lot of fake, which is a waste, or maybe you want to be able to retry individually in unicast, which is what we usually do in that case. And that would require probably a new draft in this group. And I would like to see that.
Julian on the mic.
Yes, Julien Catalano from Curling. So my
Julian,
opinion,
you have the mic.
yeah, can you hear me? Okay, so my opinion here is that I don't want to delay the SHIC over LoRaWAN document to be published because of multicast. Because I have this feeling, as you said, Pascal, that it's not yet ready in our mind that how multicast could be used in SHIC and in LP1 in general. So my opinion is that what we did in SHIC over LoRaWAN draft is a simple assumption that we could use a SHIC and SHIC over LoRaWAN for multicast, but we didn't get into the details. And I think it's sufficient for this first version.
Makes sense. I mean, I'm not advocating that we delay this document for multicast. I'm advocating that we start doing a generic multicast work for reliable fragments so that later we can have some specs in the technologies if they need it.
Yes, sure, but on the second step, right?
Yeah, on the second step. Yeah.
Yes, the second step, exactly.
Okay.
I think we all agree on that, at least.
Mm-hmm. Okay, great. Thanks.
So, Juan Carlos?
Yes, Juan Carlos. Yeah, I support the idea of, I very much, I'm very interested in this multicast discussion, but I don't see the need to delay any of the existing drafts. That's a whole new topic for rechartering and continuing the work.
It's more to define what goes in the recharter, because we are talking about the recharter and we don't have an item for reliable multicast. And the question is, do we add an item for this?
Yep.
Okay, so if you move one slide further.
Yeah, thank you for the update of the slide. You'll see that there is no multicasting. So on the ID, we just put that on the new draft, which might be the draft 5. It is recommended to create interface and identifier following the SHIC specification RFC 72970. Sorry. And RFC 8064. The other author are discussing should we remove 84, should we add 8064, sorry. So if you have any input for us on that, we would be more than happy to take it because we don't know really how to manage it. We don't want to reinvent the wheel and just stick to what RFC recommends. Then the change for the draft 5 will be the IIDs. There is some typo left and document cleanup to do. There is a new chapter to add on the bidirectionality of SHIC over LoRaWAN, like Dominique explained. We might need to find a shepherd one day or another. So if there is anyone who's feeling that he might fit, we would be more than happy to accept candidature. And we would like some feedback because we hope to put the document in last call in draft 5 or so. Okay, so if you have any question.
I have one comment about item 1. I think that we need to include Dave Thaler in this discussion, so we can actually start a thread on the mailing list and invite Dave. So if you start the thread, I will copy Dave, or I can even start it myself if you prefer. And so we'll talk about the IID selection. Yes, that's a very good point, because obviously you want something stable because you're compressing it. So 64 is good. And then privacy, I don't know. So 65 we have to look at. But basically get recommendation from Dave would be certainly interesting. So let's include him in the discussion in the mailing list. Yeah, in the corridor, you can find him, right?
And okay, so I think that we have already an excellent candidate for the shepherding, so it's not going to pose any problem, I think. So do you think that you'll be ready for a working group last call by the next IETF? Even well before
I hope
that?
so.
Okay. And one last thing, so if you have not looked already at the data model from Laurent, can you make sure to read it and to make sure that everything that is there is pertinent to what you're doing, and that everything that you need is also there?
I have a look.
Okay, perfect. Thank you very much.
Second time. Thank you.
Okay, you want me to talk about data model? Okay, so I'm going to talk first about data model. So right now there is no more data model because the draft expired, but I will renew it soon. And in fact, we work on it.
Can you please maybe do the context first?
Okay.
The co-op, and then we'll...
Okay, so I switch to co-op. So here the draft is ready because it's in ISG hands now. So we are in version 11 of the draft, and co-author Hannah and Ricardo Anderson. Sorry, it's me. Okay, so during last IETF, we moved from V9 to V11, and we make some editorial change to comply with VIG format. So the draft is compatible with BCP 14. We also modify the abstract to be more precise on what we are doing, and we also change reference because our score moved from draft to RFC. So it has been submitted for ISG for publication, and now we are expecting a return from ISG on the draft. So that's all for this one. Wow.
Okay, so just while we switch, so just uploaded also the Yang data model. So what you see here, you're also going to find it on the data tracker. So before we switch to that, a couple of questions about the co-op draft. So it is so Pascal is the shepherd, the reviewers. So next step on this one. It is then going to be reviewed by the ADs, and it's in Sura's hands. Yeah.
Yeah, so discussion, as I said before, it's in my queue, and I really hope to get it soon. Let's say within a month, like before Christmas, I want to get it off the AD eval pile. So you can work over the holidays and get it ready in January.
Okay,
Perfect.
yeah. So go back to the data model. So as I said just before, now the draft has expired, but we will publish soon a new version. And so it was not useful just to renew the number, but to work, during that time, I work a little bit more on the young model for SHIC. So the idea is to reproduce what we have in the draft, current SHIC draft. It's a table that has no real structure. It's just an explanation of what is a rule, but it doesn't define formally how to write it. So here you have a young model that describes what is a rule. So you have a rule ID, and then you can have either a fragmentation information or compression information. And compression information is a table with field ID and operator on it, and it's described on this model. So it's just a starting point. Now we have to work more on it to improve it and to make it really compatible with all the young spirit. But I think it's in a good way. And of course, the hackathon helped us also to understand what we need to put in the rule, especially for fragmentation. So for compression, it's quite clear because the draft explains a lot of things. So now what I say, we need to have some input from SHIC implementers to see what you really need to put in a young model, and for young community for compatibility with the young model. So as I say, I will publish a new version with what we have done during the past weeks or months, and then it will be a starting point to discuss on this model. And so my suggestion will be to put that item in the next interim meeting we will have, and make all the group work on this.
Yes. Do you have any questions on that?
So this will be one of the charter items.
Yeah, it is, and so that there is one point that's really important here. Especially for the technology drafts, is to talk to Laurent and Anna, to maybe one of the next interims, to make sure that you understand and that you agree with the structure. So once we agree in the group that it's good for us, then we can go to the young doctors, and they can say, yeah, that's like the way the Yang should be formatted, and make sure that it also makes sense from a Yang point of view. But it's really important point to formalize this so that we can have a generic way to represent SHIC contexts. So thanks very much, Laurent. Yes, and with this one, we move to the next presentation.
So we are out of time, Dominique, so take the time you need.
There's nothing to say anyway. Okay, so this is just a quick reminder of this draft, which has expired. I haven't renewed it for a couple of ETFs. We started writing this before I took active participation in the other draft, the SHIC draft, which kept me busy quite a lot. So just to remind people what this is about, it's about how to use SHIC to do OAM, operation administration and management of IoT devices. So the idea is to do the usual stuff that you'd expect with an IP network. We're saying SHIC allows us to bring IP to these IoT networks. And so if you bring IP, you bring a set of expectations from the engineers, technicians, that since it's IP, they can do pings and trace routes, and they get ICMP error messages, for example, when a destination is not reachable. And so this draft is first a discussion on what people expect with an IP network and what is realistic to implement with LPWAN, IP-enabled networks. So first there needs to be a use case discussion. What do we want to do? What kind of messages do we want to relay on the actual LPWAN network? What kind of responses or messages we can proxy at the core before we get onto the constraint link, the LPWAN link, and then we'll work on applying SHIC to achieve that. And namely, we can do header compression pretty easily. Do header compression on ICMPv6 messages, starting from the simple ones in RC 4441. 4443, sorry. So this is a reprint of a slide that I showed a long time ago, listing the various use cases and asking questions. Do we want this to happen? Do we want this to happen? So I'm not going to go again in this discussion since we haven't worked on that for at least a year. So we certainly expect a few things to happen, like a host on the internet pinging an IoT device that is IP enabled for SHIC. We expect it to get an echo reply to its echo request messages. We expect this device on the internet to receive an ICMPv6 response. And now the question is, shall those be propagated all the way down to the device and the response be propagated back with SHIC compression, or shall it be proxied at the SHIC core here? And so we have to go through that discussion. Yeah, so that's what I promised we would do as soon as the main SHIC draft is out of the door, which is going to happen in the next few days. So I'm expecting this discussion to resume shortly. And again, that was just a reminder of we have this ahead of us. Questions?
Okay, thank you so much, Dominique. We have no questions, so what we'd like to do is, since we have a little bit of time, is we'd like to bring up the charter text and fine-tune it based on what we just discussed. So the two discussions, the two changes that may arise in the charter, for one is the one that we presented earlier, that we want item 1 to be about maintenance. So basically any change that would be required in the SHIC mechanisms for new protocol, for new bar over SHIC. So that's one change. And the other change that we just discussed today is to accept new work on reliable multicast, which means, I guess, mostly for downstream multicast. So there is this packet for a number of nodes, and some nodes miss some fragments, and we want to be able to recover those fragments. So basically what we would like to do now is just share an editor session and agree with you guys on the text that we want to see there. Since we have Suresh in the room, let's just benefit from that. And basically at the end of this meeting, Suresh, we would be sending you the charter. So this, there we go. Okay, can you make it larger? If you can enlarge the fonts. Even more, if you can. Good. So the beginning doesn't change much. The intro is just the intro. Let's go to the bottom. And so this is the point 1. Do we want to agree on this text the way it is? Is there any change? So that's the one where we say we want new bar over SHIC. So our track document. So meaning that if the SHIC mechanism itself needs to be changed for a new bar.
Suresh Krishnan. So I understand what it means, but I don't think like borrow or shake is like a good formulation of that. So
Okay. To enable new protocols.
yeah, new upper layer protocols or shake or something like that.
So we enable them, we don't define them. So the idea would be to enable the compression of new protocols.
And if you want, you can say other than CoAP.
Sorry?
Other than CoAP.
In
Enabling
addition
new
to
upper
CoAP.
layer protocols other than CoAP over shake.
So I mean, you want to see other than CoAP written? Or in addition? Or do you want, what's the point of pointing?
Because
on
like we have already CoAP, right?
Right.
So you can just leave it as is if you want. You don't have to put a hyphen, just say, upper layer protocols over shake. And I can explain if somebody asks, like it's like other than CoAP since we did it. I thought like it'll just avoid a question, but it's fine. It's not a big deal.
So the sentence is a bit awkward now, including standard tracks document to enable upper. No. Including standard track, no, keep including, but move standard track documents before enabling.
Pascal, I think you can just leave out standard track. That's it. You can say SHIC maintenance, including enabling upper layer protocols, or that's it.
Okay. So that's item 1. Dominique?
Well, I don't quite like the upper layer protocol over SHIC. It looks like you're changing the upper layer protocol to enable it to run over SHIC.
Enabling SHIC compression.
SHIC compression of upper layer protocol headers.
Of new, okay, enabling SHIC compression. It's not just compression, so SHIC mechanisms. SHIC mechanisms for new upper layer protocols.
Well, technically, it's mostly compression. There's nothing in fragmentation that is related to the upper layer.
Well, the first thing we're going to do is upper layer protocol, which needs reliable fragments. So technically, okay. I don't necessarily agree. But okay, so item 2, are we in line for item 1? Is there? So we all know what we want to do there. It's just that, is it understandable from the perspective of the TED chat? Georgios?
Hello, there is Anna from Zaber. She proposed other upper layer than CoAP.
But what's the point of that?
That's what I suggested, but it's okay. Either way, I'm fine.
You're fine?
I'm fine either way.
Keep it simple. Yeah. So let's move to item 2. And item 2 would be about new standard track work for reliable multicast, downstream reliable multicast. So how do we want to? So it's item, well, yes, in the middle. Yes, we need to insert it. Standard track document to provide reliable fragment multicast. Reliable, because multicast we have. Yes, we want. Reliable multicast for downstream fragments. For downstream fragments. Yeah. Does that work?
Yes, Laurent. I'm not sure reliable is, I think it's too strong because we can imagine a group where you say only 90% of the device can receive this. So it's not reliable, but it's, and we never work on multicast. So for me, multicast alone will be better.
Yeah, but we already have multicast for unreliable using.
We never tested.
Just using the layer 2 multicast without any retry per layer. So I mean, it's kind of already there. You have it in the LoRa document, if you like. So maybe recoverable or something. So what's really needed is something to recover some missing fragments, right? But in a multicast fashion. Julien?
Do you want to address security?
Olivier Gimlet speaking. I want to discuss the fragment delivery because if you use forward error correction, you will not have all fragment delivered, but you will have the upper message delivered. So you don't want necessarily all fragments to be received by the device, actually.
And that's when the upper layer does its own forward error correction or something, right?
If you do that, you would say you had an overhead of 10% on each messages, so you can
It's fake.
basically lose 10%. So you don't want to put multicast fragment delivery. It's not because you can lose fragments, so it's the goal of the algorithm.
But if you have some forward error correction at the upper layer, I mean, then you don't need us. You can use the unreliable fragment and put as much fake as you need at the upper layer.
Yeah,
But then there's no need for us to do any work.
Do you know today that reliable multicast downlink on Chick will not use forward error correction? Do you know it today?
I don't know nothing.
So you can't put that here.
But all I'm saying is, if you want the FAQ to be part of Chic, then we need to standardize it.
Yeah, sure.
If you want the FAQ to be at the upper layer because you have redundancy in something, then it's not us.
That is not what I'm discussing. My idea is we can use several methods to achieve multicast fragment delivery on Chic layer. One of them might be, I don't know, forward error correction.
Yeah, it's part of making it more reliable, right?
Yeah, but if you do forward error correction, you can allow losing fragments.
Yes.
Here you are putting that you want to provide multicast fragment delivery, but we can lose them. So I think we should remove fragments.
So reliable delivery of fragmented packets, maybe, because that doesn't include that the fragments are recovered, but the packet itself is reliably
upper layer packets, not fragments.
Reliable delivery of fragmented packet.
Upper layers packets.
Of multicasted. There must be multicast somewhere.
Multicasts.
I'm Juan Carlos Zúñiga here. I'm not. It's getting more confusing every time.
Yes.
I'm not sure it's helping.
And I'd like to confuse it a bit more.
Sorry?
So I wonder if you want to also address security of the multicast channel.
Hey, Krishna. So I think it got longer, but it didn't address like Laurent's point, right? Like because Laurent's point still remains, it's not reliable. So, so if the intent is to have some kind of acknowledge mechanism, is that what you're looking for? Like, do you have some idea of like how this is going to look like?
We don't have an idea if it's acknowledgement or forward error correction of an hybrid arc or anything like that. The bottom line would be we want to improve the reliability of the multicast.
I think like that's kind of what I was going to suggest, right? Like standard stack document that like, provides an improved mechanism for delivery to
provide improved reliability.
Yes,
Or to take. Suresh, I didn't catch what you said. Can you please repeat? So that provide an improved mechanism for?
That describes an improved mechanism for increasing
We don't have a mechanism, so we can't improve it.
It's long, but it at least addresses this point, right? Like, so that's kind of what I was suggesting. There's no easy formulation for this, right? Because it's not reliable, but we already have multicast delivery. So it's a very small niche, right, that you're trying to fill, because at the end result, it's not going to be fully reliable either, right?
So we want a more reliable delivery of multicast packets that go fragmented.
Yeah, but it's long too. So like I'm just saying, the problem area is niche. So you're not going to have like an easy statement of this, right? So I think like, just describe what you want to do. Just say like, try to improve the reliability of multicast fragment delivery. That's really what you're trying to do.
Oh,
right?
That was nice. I love that one.
Yeah, exactly.
Improve the delivery of multicast packets that are fragmented.
To provide a mechanism
to improve the delivery,
improve the reliability, delivering multicast packets.
Of multicast packets.
Reliability of delivering multicast packets. Laurent, did that work for you? Or?
Well, it's missing the fragment prime, because if it's not fragmented, then it's another story.
Just say multicast fragments.
Well, no, now we're back to Olivier's prime, which is it's not a fragment that we want to, so it's the fragmented packet
But what we do is
of fragmented multicast packets, something.
we take IP packets and then we compress them. So if we have an IP multicast packet, then we have to improve the way we deliver this to the nodes. And so
Sentence?
here I will keep, so I will.
Wait, we're jumping in solutions here.
No. But efficiency more than reliability and multicast packet.
Efficiency is good, I like it. Stu?
Hi, Stu Card. We're not trying to achieve reliable delivery of fragments. We're attempting to achieve reliable delivery of data that just happens to be fragmented.
Yes, that was Olivier's point.
And I don't think we need to talk about improve the reliability because no one expects 100.0% reliable. Reliable is a different word from assured, right? Assured talks about you got it and you got some kind of acknowledgement that you got it, whereas reliable can include statistical reliability. Now, having just said that we're not trying to achieve reliable delivery of fragments, I will now reverse myself and say that one way to achieve reliable delivery of data that is fragmented is to use a type 2 hybrid ARQ FEC, such as is standardized in RFC 5740 at the transport layer.
Okay. So final attempt, like change the multicast fragments to fragmented multicast packets.
Change fragment into
Okay, I'm done. Thanks.
We don't say make them fully reliable. We say improve reliability, right? So it gives us some room for imperfection.
Okay, so that sounds. So, do you? How does the room feel? Can you give a hum on this on the second point? So, if you agree with this formulation, okay, do you agree with this formulation? Please hum now if you agree. Okay, so yeah, if you disagree, please hum now. Okay, so nobody's humming, so then that's good. So sorry, yeah, okay, we'll need to confirm that to this one on the list.
Can you scroll?
Yes. Okay.
So we can't have it all in the same page.
Yeah. Okay, maybe we can have it if I do it like this. So the other ones are basically topics that we have discussed for a couple of IETFs now. So I think this one was the hot new, the new topic that came from recent discussions.
Hi, Carlos Gomez. In Montreal, we discussed also the idea of working on RTO for LP1. So I don't know if it's kind of independent from the points here, or
yes, I don't. So yeah, we had your presentation. I'm not sure if that one got discussed further on the mailing list. I don't know if we need to add this one as as an item that we would like to work.
Carlos, I'm sorry, but I've not seen enough activity right now to feel confident that the group wants it. So you can post as a response. We'll post that. You said, hey, the mailing list, we had this RTO discussion. If we see enough noise on the mailing list to support that we also include RTO, we'll propose to Suraj. I've not seen so far that I would not feel safe right now. I'm sorry.
Yeah.
Maybe one point to add on this one is I feel that with this 5 points we'll have a lot of work for the next couple of months. I did like your work, so probably if you continue developing the work, we'll be able to include it next time when if we do a small recharter. I think that can be fairly easy to achieve compared to the points that we have here. So please continue the work. I think I feel that it's something valuable and we can include it. So Suresh, thank you. Thank you, everyone. This is the end of the meeting. We'll confirm this on the mailing list and we'll end the recharter. Thank you all.
Just one point about point 4. I think it will be better to put it after point 1 because it's full and bar, and then the rest.
Okay, we'll remember. Thank you. Thank you all, and thank you for the wonderful work, and see you in Vancouver.
Thank you all.
Thanks so much.